What is friction loss in fire pump operations? Imagine trying to water a garden with a garden hose. The longer the hose and the smaller the opening, the harder it is for water to flow. Now, think about firefighting hoses that are much larger and longer. When firefighters operate fire pumps, they need to understand how water moves through all that equipment. One key factor they must consider is friction loss. Friction loss happens when water flows through hoses, fittings, and appliances. It is the pressure drop caused by the resistance water faces as it rubs against the interior surfaces of the hose and equipment. This resistance slows the water down and reduces the pressure at the nozzle. If the pressure drops too much, the fire stream won't reach the fire effectively. Water flow inside hoses can be smooth or turbulent. In firefighting, turbulent flow is more common because hoses often bend or have fittings that disturb the flow. Turbulence increases resistance, which in turn increases friction loss. The more turbulence, the more pressure is lost. Friction loss is measured in pounds per square inch. It depends mainly on three things: how much water is flowing, the diameter of the hose, and how long the hose is. Smaller hoses create more friction loss because the water has less space to flow through. Longer hoses also cause more loss because resistance adds up over distance. For example, flowing 150 gallons per minute through 100 feet of 1.5-inch hose causes about 55 pounds per square inch of pressure loss. But if you use a 2.5-inch hose for the same flow, the loss drops to around 5 pounds per square inch. That's why larger hoses are better for high-flow situations. Fire pump operators need to calculate friction loss to set the right pump discharge pressure. They add the friction loss to the nozzle pressure, any elevation changes, and pressure losses in appliances like Y's or Siamese connections. This helps ensure the water reaches the fire with enough force. Understanding how friction loss works helps firefighters deliver water efficiently. If they underestimate it, the fire stream may be weak and not reach the fire. Overestimating it can cause unnecessary strain on the pump and waste water. Firefighters often use tables or formulas to quickly figure out the pressure loss based on hose size, length, and flow rate. In practice, they add the calculated friction loss to the nozzle pressure needed for effective firefighting. This total is the pump discharge pressure they set on the fire pump. Managing friction loss properly ensures the fire stream is strong enough to control the fire and keep everyone safe. So, in simple terms, friction loss is the pressure drop caused by water rubbing against the inside of hoses and equipment. It's a vital part of fire pump operations because it directly impacts how much water gets to the fire and how effectively it can be fought.